Today's lesson has been brought to you by Limitless Learning TT. For additional videos and more information on the services we offer, please visit www.limitlesslearningtt.com. You can send us an email at limitlesslearningtt@gmail.com, or you can always call us at 868-354-3115. In today's lesson, we will introduce you to sets. What is a set? A set can be thought of as a collection of things. Let's use an example. Fruits that you eat. And let's say some of the fruits you eat are oranges, apples, mangoes. Then this could be thought of as a set. The set represents the fruits that you eat. Now, how do we represent a set? Let's look at notation. So the first thing we use to represent a set are curly brackets or braces. Then within our curly brackets or braces, we're going to put the elements or items that are within our set. So we're going to use the example fruits that you eat, and the elements that are within our set are going to be oranges, apples, and mangoes. So we're going to put that within our curly brackets, and we're going to separate them by using commas. So this set represents the fruits that you eat. Just to recap, the curly brackets are known as our braces. Oranges, apples, and mangoes are known as our elements. And our elements are always separated by commas. Now let's look at another example. Let's look at the set with elements 2, 4, 6, and onwards. So we have our braces or set brackets. We have elements that are within our brackets, and then we have 3 dots. These 3 dots mean that our numbers go on forever. This is what we call an indefinite set, as in there is no end to the set. So it will be 2, 4, 6, 8, all the even numbers until we can ever stop counting. So once you have 3 dots that are at the end, this represents an indefinite set, meaning that it goes on and we don't know how many elements are within the set. It's important to know that indefinite sets are represented when there are 3 dots that are at the end of our set braces or set brackets. So this represents an indefinite set. Okay, let's look at another example that uses these 3 dots. Let's say that our set is the alphabet, and we're going to write it as a set that contains A, B, C, D, and so on, and then it finishes with X, Y, Z. Now in this set, our 3 dots are within the middle. It's not at the end of our set. So what we're saying is that we have the letters A, B, C, D, and you can tell that that's how the alphabet starts. So the dots represent all the letters that are in the middle, or all the letters that are between D and X. So because we start with A, B, C, D, we know the letters that are in the middle, and we end with X, Y, and Z. This set, we know exactly how many elements are in our set. We have 26 elements representing the 26 letters in the alphabet. So this set is a definite set, which means that we know exactly how many elements are in our set. Because the 3 dots are in the middle of our set and it's not at the end, it means that it's not going on forever. We know that it ends at Z. Therefore, this represents a definite set. Another important thing to note when we're talking about notation, the elements of a set are always in common letters. So for example, as we had the set that contains a letter of the alphabet, letters of the alphabet, A, B, C, D, and so on until X, Y, and Z, you realize that the elements are all written with common letters, whereas the name of the set, or the big set itself, is represented by a capital letter. So let's say that we're going to call this set with the letters of the alphabet, set A. That set A will be a capital letter A, and then we'll put the equal sign, and then we have the set that contains the letters A, B through Z, and those elements are always represented by common letters. Okay, let's use this same example with the set A is equal to the letters that are in the alphabet. We can see that B, the element B, is part of the set A. We can write that notation down by putting B, and that's little b, is an element of, which we write as this fancy notation, of the big set A. Okay, so little b represents an element, big A represents a set, and this symbol in the middle represents, is an element of, or is a part of the set A. We can also see that there are no numbers that are in this set A. So therefore, the number 1, for example, is not in the set A. And we represent the symbol is not by putting a strike through is an element of A. Okay, so the is an element sign looks like an E kind of, and is not an element of has a strike through that symbol. So this symbol means is not an element of. Okay, so let's just do a quick recap. Whenever we're representing a set, we need to have our braces. Those are our curly brackets that are at the beginning, at the end of the set. Then within our braces, we have elements that are written either as numbers, or if we use letters, they must be common letters. And the set itself, is in the name of the set, is represented by a capital letter. We also know how to write the symbol for an element of, showing that an element belongs to a set. And we also know how to write the symbol for is not an element of, to show that a specific element does not belong in that set. Now we're going to look at some special sets. We're going to start with the universal set. The universal set can be thought of as a set that contains everything that's relevant to our question. So let's suppose that we're talking about a set B that contains the elements P, Q, and Z. Our universal set, which is represented by a capital U with a script, or like a fancy U, could be the letters of the alphabet. So therefore, the universal set in this example is a set that contains everything relevant to our question, because our question entails the set B, which involves the elements P, Q, and Z. So in this example, our universal set can be represented by the letters of the alphabet. So the official definition for a universal set will be the set containing all objects or elements, and of which all other sets are subsets. So I'm just going to write down that definition, and we will explore that further. Now, our definition of universal set mentions something that is known as a subset. We will explore that term further on in this video. Another special set that we want to take a look at is known as our empty set or null set. An empty set or null set is a set that has no elements. This is usually represented by curly brackets that have no elements in it, or by this following symbol that looks like a 0 with a line crossed through it. So these are the two symbols that represent an empty set or null set. And again, an empty set is a set that has no elements. So an example of that can be the set of squares that have 5 sides. Now you know that a square has 4 sides, so a square that has 5 sides doesn't exist. Therefore, that's an example of an empty set. Now let's talk about subsets, a term that was brought up in our definition of universal set. And a subset is known as the part of a set. And the best way to really understand that definition is by looking at an example. So suppose we have a set A that has elements 1 through 5. So a subset of A is any set that is a part of A. So for example, if I had the set B that entailed the numbers 1 and 3, 1 and 3 are elements that are part of the big set A. So therefore that means that B is a subset of A. Another example, suppose I had a set C that had the elements 2, 4, and 5. Since the elements 2, 4, and 5 are also part of the set A, that means that C is a subset of A as well. So the official definition for a subset is B is a subset of A if and only if every element in B is in A. And if we look at our example, every element in B would be 1 and 3 belongs to the set A. Therefore, in our example, B is a subset of A according to this definition, as is C a subset of A, because every element that's in C, which is 2, 4, and 5, is in the set A. And just some notation, is a subset of is represented by this sign, and is not a subset of is represented by this sign or symbol. So now we can rewrite B is a subset of A as, and we can rewrite C is a subset of A as. Next, let's look at the equality of two sets. Two sets are equal if they have the same elements. So let's look at our set A and let's look at our set B. Now in this example, I'm saying that set A and set B are equal because they have the same elements. It doesn't matter that the numbers are not in consecutive order. A contains the numbers 1, 2, 5, and 7, and B also includes the elements 1, 2, 5, and 7. So therefore, since sets A and B have the same elements, it must be that set A is equal to B. Next, we're going to look at the intersection of sets. The intersection represents the elements that are common to two or more sets. It is represented by this symbol. Let's look at an example. Let's suppose we have the set A that contains the elements 2, 4, and 6. B is going to be the set that contains the elements 1, 2, 3, 6, and 7. And C is going to be the set that contains elements 1, 2, 4, 7, and 10. The first part of our example asks us to find the intersection of A and B. So we write that as A, the symbol for intersect, B. And we're looking for the elements that are in set A and are also in set B. So we're only looking at set A and set B. So we can see that both of them have the number 2. And both of them have the element 6, and those are the only elements that are common to the set A and B. So therefore, A intersect B is going to be the set that contains the elements 2 and 6. The second part of our example asks us to find the intersection between the sets B and C. So that means that we're looking for the elements that are common to set B and set C. We're going to write that as B intersects C. And if we're looking at sets B and C, we're looking for elements that are in both of these sets, and that will be 1, 2, and 7. So therefore, B intersects C is going to be the set that contains elements 1, 2, and 7. And the final part of our example asks us to find the intersection between the sets A, B, and C. So we're looking for A intersect B intersect C. That is the intersection of three sets. So that's written as A intersect B intersect C. So that means we're looking for elements that are in set A. They also must be in set B, and they also must be in set C. The only elements that are in the three sets will be the element 2. Nothing else is common to sets A, B, and C. So therefore, A intersect B intersect C is going to be the set that contains the element 2. Next, we're going to look at the union of two sets. The union represents elements that are in either one or both of the sets. You can think of union as combining two or more sets. Okay, so let's look at an example. We're going to use the same sets from before. That is, A is a set that contains 2, 4, and 6. B is the set that contains the elements 1, 2, 3, 6, and 7. And C is the set that contains the elements 1, 2, 4, 7, and 10. So the first part of our example asks us to find the union of sets A and B. Now the symbol for union looks like the opposite of the symbol for intersection. So the symbol for union looks like a U. The first part of our example asks us to find the union of sets A and B. So that's represented as A union B. And what we're going to do is to combine the sets A and B, but we're not going to double count an element. So if we're combining the sets A and B, that means it must have 1, the element 1, since that is in B, the element 2, which is in A and B, the element 3, which is in B only, the element 4, which is in A only, the element 6, which is in sets A and B, and the element 7, which is in just the set B. So to find the union, what we do is combine both sets, and we only write the elements that are in both sets once. So A union B is the set that contains the elements 1, 2, 3, 4, 6, and 7. Let's look at a second part of our example, which asks us to find the union of sets A, B, and C. So that's written as A union B union C. And what we're looking to do is to combine the elements that are in all three sets. So that's 1, which is in B and C, the element 2, which is in A, B, and C, the element 3, which is in B only, the element 4, which is in A and C, the element 6, which is in A and B, the element 7, which is in B and C, and the element 10, which is in C only. So we would have combined sets A, B, and C, and that's union. So A union B union C gives us a set that contains elements 1, 2, 3, 4, 6, 7, and 10. Let's look at one final example that combines everything that we would have looked at in this session. So let the set A contain elements 1, 2, 3, and 4. The set B contain elements 3, 5, 7, and 9. And the set C contain the elements 1, 10, and 12. Part 1 asks us to find all the subsets of set C. So let's recall what is a subset. So remember, B is a subset of A if and only if every element of B is in A. So basically, subsets are smaller versions of big sets. So let's look at our question again. So we're looking for all the smaller sets that would be a part of the set C. So we'll start with listing elements, or listing a set with one element in each set. So the set that contains 1, the set that contains 10, the set that contains 12. And these are all subsets of C because every element in each one of these sets also belongs to the set C. Now let's list sets that have 2 elements in it. So 1 and 10. And remember, the set that has 1 and 10 is the same thing as the set that has 10 and 1. Order doesn't matter. So again, set 1, the set that contains 1 and 10, the set that contains 1 and 12, the set that contains 10 and 12. Now we're going to look at the set that has 3 elements in it, and that set will be 1, 10, and 12. And that is also a subset of C because every element that's in 1, 10, and 12 is also in set C, which is 1, 10, and 12. So right now we have 1, 2, 3, 4, 5, 6, 7 subsets, and we always remember that the empty set is always a subset of any set. So the last thing that we're going to include is the empty set. Part 2 of our example asks us to find the union of sets B and C. So we know that finding the union of sets B and C can be written as B union C, where union is the symbol that looks like a U. So we're going to combine our sets B and C. So starts off with element 1, which is in C only, element 3, which is in B only, element 5, which is in B only, element 7, which is in B only, element 9, which is in B only, element 10, which is in set C only, and element 12, which is in set C only. So B union C is a combination or putting together the elements that are in either or set B or C, and that's going to be represented by the set that contains elements 1, 3, 5, 7, 9, 10, and 12. And now the third part of our question asks us to find the intersection of sets A, B, and C. So this can be written as A intersect B intersect C, and we know that the symbol for intersection looks like an upside down U. So when we're looking at the intersection, we're looking at elements that have to be in set A, and they must be in set B, and they must also be in set C. So let's look at our elements in our sets A, B, and C. As we're looking at the elements in each one of these sets, we realize that there is no element that is in A that is also in B and that is also in C. So there is no set that has any elements in our intersection of A, B, and C. Therefore, we recall that is the definition for an empty set. So that means that the intersection of A, B, and C is the empty set, a set that has no elements. And we represent that either with this symbol or by writing curly brackets with no elements inside. That's it for today's lessons on an introduction to sets. For additional videos as well as more information on the services that we offer, please visit www.limitlesslearningtt.com or send us an email at limitlesslearningtt@gmail.com, or you can always give us a call at 868-354-3115.